Hello again, welcome to my class. My name is Teacher Hura, and in this video, we're going to learn more about the empirical formula. So the empirical formula of a compound shows the simplest whole number ratio in which the atoms combine to form a compound. So the most important thing here is to learn that it is the simplest whole number ratio. So you can see it shows that simplest whole number ratio in which atoms combine to form a compound. Now, in a previous video, I showed you some basics on the empirical formula. Today, we're going to advance that a little bit. I carefully choose the questions I show you in these videos so that they can help you learn a new concept every day. So let's go straight up. All right, so this question says that an organic compound contains 6.0 grams by mass of carbon, 1.0 gram of hydrogen, and 4.0 gram of oxygen. Determine its empirical formula. Now, the way to determine the empirical formula is very easy. So the first thing you do is to check what elements are present in that compound. So this compound contains carbon, hydrogen, and oxygen. And then now, the next thing that you do is to determine the mass of each of these elements present in the compound. And that has been given in the question as 6 grams for carbon, 1 gram for hydrogen, and 4 grams for oxygen. So you write there the mass of each of them. Then next is to determine the relative atomic mass of each of these elements. So the relative atomic mass is usually given in brackets right here. So these numbers here represent the relative atomic masses of each of the elements. Then next is where we get to my exciting part, the mole. So we calculate the mole of each of these elements present in the compound. So here, the mole, I gave you the formula, is given by the mass divided by the relative atomic mass. So it is simple. So you just take whatever you have here, divide what you have here. So if we start with the first one, you'll get 0.5. This one you get 1.0. And so this gives you 0.25. Then the next part of this is to calculate the mole ratio. And just remember, the mole ratio is determined by dividing by the smallest figure of the smallest mole ratio. So you'll get that this one, and this one. Look for the smallest one. The smallest one is 0.25. So each of these mole values are going to be divided by 0.25 to find the simplest whole number ratio. So we have a 0.5 divide 0.25. This gives us 2. 1.0 over 0.25, this gives us a 4, and 0.25 divide 0.25, this gives us a 1. So that means that these elements, the combining ratios for these elements is a 2, a 4, and a 1. So the empirical formula for this compound is going to be C2H4O. So that's it. Let's go to the second question. So in this question, you have 13.7 grams of an oxide of lead was completely reduced over heated carbon, and 12.42 grams of the metal was deposited. Find the formula of this oxide of lead. So this procedure is the same, and that's why the mole is quite simple, because everything, they follow each other and they have a certain pattern that will always be used. So first things first, we have the element. So the elements present in an oxide of lead is lead and oxygen. The next is to get to the mass. So now that we have 13.7 grams of an oxide of lead, if it was reduced to 12.42 grams of the metal, that means this is the mass of the metal. Metal here is lead. So the mass of lead is 12.42. The mass of oxygen is going to be obtained by subtracting 13.7 minus 12.2. And that gives us a 1.28. Now that we have our values for the mass, we need to move forward and talk about the relative atomic mass. Once again, you check out the numbers in bracket here you've been provided with. So the relative atomic mass of lead is 207 and that one of oxygen is 16. Next is to calculate the moles, and we said the moles are gotten by taking the mass, divide the RAM. When you calculate this, you end up with 0.06. Then on this other side, we calculate and we have our 1.28 divide 16. So when you calculate this, again you punch in the calculator and you end up with 0.08. The next part is to calculate the mole ratio. The mole ratio is gotten by dividing by the smaller value. So between this and this, the 0.06 is the smaller value. So we divide 0.06 divide 0.06 gives us a 1. 0.08 divide 0.06 gives us a 1.3333 recurring. Whenever you get a recurring decimal like this one, then you better use the fractions, improper fractions. So we're going to change this into its improper fraction, which is a 4/3. Now that is the one that you're going to use to eliminate the decimal, because now this is no longer a whole number ratio. So now using this, we need to multiply both sides by 3 in order to get our combining ratio. Now our combining ratio becomes 3 and 4. So our empirical formula for this oxide of lead is, and that's how it is done. So you can see this time I made sure that you get the answer where it is recurring. So whenever you get a recurring decimal, especially a 0.333 or a 0.666 recurring decimal, you convert it into the improper fraction, and that one you'll get a decimal, a denominator that you can easily multiply by, and you eliminate the decimal place. So that is how you calculate the empirical formula. I hope you enjoyed this video and you learned something. Give it a thumbs up and do not forget to subscribe if this is your first time. Turn on that notification bell because I'll be posting in more videos for you every day for free.